Okay, it's already recording. Should I wait for? Okay, I think we already have good enough number of people in the class. So let me share my screen straight up. Um, I'm hoping that you can see my screen. I think my screen is visible.
Yes.
Okay, so I figured that when I was checking the questions, I just figured that it will make more sense. I know I think you are Roslyn, right? You sent a
Yes, Titilope, Rosie Titilope.
you sent a PDF with the answers, and by the time I was cross checking it, I figured that it will make more sense trying to understand the question. If you understand the questions, like how it works in actual sense, it's easier to even answer the question, like freestyling it without anything serious. So I just figured that it's better we have like a class just to discuss it, then we can now form our note from it. So yep. So I'm already recording the class for people that will not. This was when I was still trying to. I was thinking we were going to have the Boolean class online as at that time. So yeah. So let me just clean up all of this. Yeah. So um, compiler design. Yeah. So the first question. So the first question states that if you check the first question, it's a lexical analysis and language design question. So it says that there's a
Mm-hmm.
financial analytic firm that is developing a domain specific language for real time risk modeling. And these are what the language supports. So it supports a floating point with optional exponential. It supports identifiers beginning with a letter, followed by letters, digits, or an underscore. Then it also supports nested multi-line comments of the form. This is a comment style. Then it also supports reserved keywords, risk model, and simulate. So they want us to design, like using this domain specific language, they want us to design a regular expression for the following token class. First one is an identifier. The second one is a floating point number with optional exponential. Then the third one is a reserved keyword. So because they've already given us like the domain specific language, this is very, very important. I think the first time I was trying to answer it, I did not put this into notes. Let me see if I can just copy this into this so that it's easier for me to see. Okay. Yeah. So I did not put it into notes that I did not put the domain specific language into notes because you can create a reserve word for maybe SQL or for other language or C or Python. They might have different ways in which you create a regular expression. So to design this regular expression, we are told the first one is an identifier. So I want to create an identifier, identifiers. So basically, an identifier they typically start with. So we're told that
Letter.
if you check here, we're told that the identifier must begin with a letter,
Letter.
letters,
Yes.
then it must be followed by letters, then followed by digits, then or underscore. So it may be followed by digits or underscore. So to build this identifier now for for a regular expression, so it is going to be so the regular expression, the regex will be can you please mute your mic? So the regular expression will be this. If your mic is on, please mute it, please. Thank you. So this is what the regular expression is. So I'm going to explain each one I will explain each one now. So this is what the regular expression would look like. Now, it's in different parts. So this is the breakdown for this. Now, the breakdown for this is you would see that the first bracket, which is this bracket, means that we were told that the identifier takes letters. It means that the first one can be letters, the first word. That is what this first part, that is what it is. It is for taking in letters. That is, um, it can take in letters A to Z, which is lowercase, and it can also take in letters A to Z, which is uppercase. Assuming it was stipulated the type of case it can take, assuming we were told that it can only take in uppercase now, then we would not need to add this to the regular expression. But because we were told letters, so it means it can either take in normal letters, that mean lower cases, or it can take in upper cases from A to Z, right? So the second part, which is um, the second,
Please, before you move forward,
yes, I'm listening.
that means in this case,
Yes.
that means you really don't need to write letters, digits, or
No,
shey you get,
this is
like just a letter. The main purpose is just starting with a letter.
yes.
Shey,
The first
yeah.
one is
So that means you don't need to the one you write at the top, the identifiers, letters, digits, or
the one I write
this
at the
stuff.
top is the instructions. We're told by that
Where is this stuff?
you will see it in the instruction. So if you check the question, I did
Okay.
not check this when I was doing it at first. It was when I checked this that I now understand that this is what they actually want us to do. For example, if you write,
But
if you
if you are following what they said, that means the example is not correct, abi?
wait, I'm coming. If you check,
Because
I'm coming. If you check rejects for identifiers now, check rejects for identifier, you would see something like this. There are different ones. It depends on, yeah, you see, this was what I even saw. You see something like this. This type. This is what you would see in actual sense. But
okay,
the instruction they gave us is that they want our identifier to begin with a letter that is a single letter. So that letter, it must, let me rewrite this. Begin with letters, begin with letters. So it must begin with letter. That's the first instruction. Then followed by this. So it must begin, you check it again. Identifier beginning with a letter, followed by letters, digits, or underscore. Do you get it now? So
I get it.
let me explain fully. So I've explained the first part, which is the first part is letters. I mean letter, basically not letters, letter, sha. Letter, it could be it could be any letter. It can either be lowercase or uppercase. Assuming we're told that uppercase letters now, for example, we would not need to write the lowercase part. So the second part is now A to Z, 0 to 9, underscore. Yeah. So this second side is because we are told that the initial letter is must be followed by, it can be followed by any of these things. It can be followed by letters, just like I explained, uppercase or lowercase. It can be followed by digits, and digits is from 0 to 9. And then specifically, we are told that it must be followed by or an underscore. That is, it allows for an underscore to follow it. So that is why we have an underscore there. Did we get this?
I get it, but I want to ask another question.
Wait, I'm coming. So now let me now do the last one, which is star. What is star at the back? What it does is that it means that this that we have, you know that we're told that it begins with letter actually. It begins with letter,
Mm,
then followed by
mhm.
letters, digits, or underscore. So it means that this case, the second case, can be repeated severally. That is, it can occur zero or more times. So that is basically what this star at the back, that is what it does. That is, this other part can reoccur as much as possible. So do you want to ask a question? Does anyone have a
Yes.
question for the if
So with
you Yeah, I'm listening.
with the rules they gave us to
Yes,
follow,
yes.
begin with a letter, then
Uh-huh.
follow by letters
Letters,
and then
followed
digits
by letters, digits, or
underscore
underscore. Yes,
or underscore.
yes.
So can I say that student one is an example.
Can you say that what? Yes, student one.
Student like
Yes,
student
student.
student one
Yes, yes, is an example.
student one
Yes, it is.
is an example
Yes, yes, yes.
instead of having all these plenty
Yes, yes.
um
Okay. Oh, yeah.
plenty
Yeah. I
letters.
will talk about. Okay. Sorry, I missed that. I'm going to talk about examples. So examples could be. So e.g. could be student one. It could be place place 45 underscore. It could be something like this. So it could be any of these things. What it cannot be 4 place 2, for example. It cannot be this. So we'll still get to that when we get to, I think there's an example, there's a question that has to do with that when we get to that. So for the first question, which is identifiers, this is identifier. This is for identifier. So now we want to move to the second question, the B part, I mean the second part, which is floating point with optional exponential. So does any other person has a question before I move to the next one? Are we clear here? Are we clear on this? Are we all clear on this?
I'm clear on it. For
Well,
me, I'm clear.
okay, good, good, good. Okay. Although I'm recording it, so I'll probably put it on YouTube when I'm done immediately, so you can probably rewatch if you don't get it. So for the second part, we're told that we want a floating point with a floating point with a floating point numbers, a floating point number with optional
External exponents.
exponential. So actually, for those that are versed with computer and how it works, floating point are basically decimal points. So this is a floating point. This is a representation of a floating point, and we are told with optional exponential. So exponential is maybe something. For example, this is an example of what they want, right? So now we want to represent it in regex now. In regex is basically regular expression. So we want to represent this in regular expression. So this is what the regular expression looks like. And I'm going to explain this. I'm trying not to miss out anything. Now, let's break down our regular expression one by one. This looks like a lot, but it is very, very simple. So for the first part, it is 0 to 9 plus. So what this first part basically means is that representation of numbers from 0 to 9. Now, what the plus at the back means is that you can represent it more than once. That is, you can it doesn't stop at writing one. It means you can write one, two, three. Like you can keep rewriting the numbers. So the plus is basically re-representation. So that is what the plus that is at the back. That's basically what it is for. That's what the plus at the back, that's what it is for. So that you can re-represent it. So that is what the first part, that is what it does. Right? So now that we understand it, so the next part is in bracket. Is someone raising his or her hands? Okay, yeah, David.
Yeah, sorry, I also need to confirm the difference between plus and asterisk. Because when we're doing the first part, we mentioned that that asterisk meant that okay, we have many multiple like
Yes, multiple
repetition
numbers.
of
Yes.
those A to Z.
Yes.
Yeah. So, but now the plus here, we also say it means that those numbers can appear multiple times. What exactly is the difference between the plus and the asterisk?
I actually did not check this out, but I'm guessing that for numbers, for actual numbers, I guess that they use plus. I'm actually guessing. I've not checked the reason for it. Maybe I will check later, Sha.
Okay, no problem. Thank you very much.
Yeah. So the second part is the bracket. So we have this dot 0 to 9, then plus I think the yes, I missed something here. This should be closed. Okay. Then closed plus okay. So what the backslash, what it does is just more like a new space or new number, new entry basically. So the backslash does not really mean anything, but it is needed. And the reason it is needed is because we want to incorporate dots, because we needed to show dots, just dot only. So the reason we have this backslash is for the dot. Then we have our normal 0 to 9, the number. Then we have the plus, that is, we can rewrite the 0 to 9 multiple times. Then what this question mark, what it does is that it is optional. If it is optional, looking at it now, I don't think we need this to be optional. I don't think this is not needed to be optional, because we are told that floating point number with optional exponential. So I think it's the exponential side that is optional, not the floating point. So I don't think we need this at the back now, thinking about it, right? But the question mark is to show that it is optional. So the next part is now the second bracket, which is then plus plus or minus, um, then question mark. So this is the part of the exponential. So the means that your exponential can be represented as a small e or a capital E. Then also your after the exponential, it can be a positive exponential or a negative exponential. That is basically what this plus or minus, that's basically what it is for. Then just like I explained the other time, this means that it is optional. It means it is optional. That is what it means. You can probably recheck it, but looking at the DLS now, the language that was given or the instruction that was given, I don't think that this is needed. But if you check normally, rejects for floating points, floating points is going to have okay. It's not showing. It's not showing what I need it to show. But if you check, it is going to have that question mark before, like after this point. But considering that they told us it's a floating point, it means that part is not optional. The optional part is the exponential. So yeah. So exponential optional. Of course, if you write an exponential, it means that you have 0 to 9, that is numbers after it, then multiple times, and then then optional. The numbers can be optional since the exponential is optional. So we understand this. So it means the number can be 34.56, This is an example. Or it can be 34.56 E minus 2, or it can be 124 dot E E5. So this can be, your rejects can be represented in any of these. Considering that we were already told that it's a floating point, it means we cannot write it as this because the float is not an option. It is a floating point, so it means it has to float. It means the extra numbers has to go with it. Do we understand this part? Any question?
Yes,
Okay.
for me, I understand.
Okay, so I think we are good in that part. Then the third part is keyword, and we are giving the specific keywords. So the keywords are risk, model, and then simulate. So these are the keywords. So to represent keywords, the reject for keyword is just risk. This in between is or, either risk or model or simulate. So these are the keywords. So this is one is basically for the keywords. Now, the next question is basically an explanation. It's an explanation of why, um, explain why nested comments cannot be fully handled by a regular expression, and describe how a lexical analyzer can still support them in practice. So, from the lot of notes that I have here, this is a note, but the basic reason why it cannot support it is because, um, so you can probably take notes, you can probably write this. I don't want to type. I think it's easier if I just call that part. So, nested comments cannot be fully handled by regex, by regular expression, because they represent a hierarchical recursive structure rather than a linear language. And okay, I guess I would probably just send this part. I will probably just send this part on the group. But the core reason Isha cannot handle it is because it does not recognize the way comments are. You know, comments are like this. So it does not recognize where to start and where to stop for these comments. So the only way lexical analyzer can handle nested comments is by using procedural codes or specific counter. I'll probably just send this, or you can probably just check that on your own just to understand that part. So now the next part is for us to, that is the C. The C is for us to distinguish between, so we want to distinguish between lexical error and syntactic error, and then give one realistic example of each from our DSL. Yeah, from our DSL. So I think someone is raising hands. Yeah, Ide, you can ask your question, please. Ide, you can ask your question. You are raising your hand. For the 1B, okay, I'm listening. For the 1B, yeah, I'm listening. You can ask your question. You can unmute your mic. For the 1B, I'm probably going to send my own answer, or you can search. I don't know. I think because I tried to check it one by one. I was trying to check.
All right. Good afternoon, everyone. Sorry, I'm in a bit of a noisy place, so I can't.
Okay, okay, no problem.
Um, but what I wanted to say is that um, it's not like, because you mentioned that it cannot undo comments, but it can undo comments, but it cannot undo multi-line
Multi-line
comments.
comments, yes, and
Because
because our
yeah,
comment is a
because it's
multi,
not neural. You said
because our comment is a multi-line comment, yes.
okay. So that was what I just wanted to
Yeah, I
say.
think assuming the
And also for the example you gave
yeah,
on this 125.E5,
yeah.
I don't know if that's correct because it cannot be a floating point if it doesn't have like
Oh,
something behind the
sorry,
point.
yes, true. Thank you, thank you, thank you.
Alright.
Yeah, thank you, thank you. If it's um if it's a single line comment, like say this, now this is a comment, I think he's going to handle it. But I think because our DSL has a multi-line comment, this is to take in multiple lines of comments in your code or whatever it is. So thank you for that. Thank you. So the next part is we are taught to distinguish between lexical error and syntactic error. So I think there are three types. There are three types of this. There is lexical error, syntactic error, then there is also semantic error. But we're taught to distinguish between the two between the two errors, and we are to make use of so this is where the DSL is important. I think the first time I was checking it, I was just using random examples. Then I saw that we are to make use of examples from our DSL, that is from our domain specific language, from what we were given. So from our domain specific language, so basically lexical errors are basically like they are basically errors where maybe the sequence of character do not match what we have in our DSL, in our domain system. So our domain system language, whatever we've defined here is probably is stored in a source, that is stored in our is stored on our compiler. But now, when it is checking for, by the time we are running the code, when it is checking for what we wrote, maybe we wrote a particular code now, by the time it's checking for it and it does not find certain things that based on the instructions. So these are more like an instruction that we've given it. So when it's checking for those instructions and it could not find what we have here, then it's going to be an error. So lexical error is going to be if there is a sequence of character that do not match the pattern of any of our tokens that we've given, that is these instructions that we've given. And if it could be a spelling error, it could also be that the length of our identifier exceeded the usual contact, I mean constant, or it could be that there is an illegal character that appears. So for example now, let's say for example, I wrote risk margin hash now. Let's say I want to declare a variable and then I wrote the variable as this, for example. This is going to give a lexical error, and that is because when we were declaring identifier, our identifier can only take letters, digits, and underscore. Hash is not part of the underscore. By the way, you might be wondering why we have risk. Risk is a keyword. So when you want to write a query, you state the keyword before the. I think that yeah, that is how it works. Before I was using, because I'm much more conversant with SQL. I was using SQL examples before I found out that um, I could use. So let's say if it's SQL now, for example, let's say you write let's say you are looking for something in SQL, and then when you now write from, you probably added a word that is not, maybe when you are declaring your table now, or maybe when you are writing the column you want to search for, you probably write let me use margin 2. You probably write margin hash, for example, or this is going to give an error because when we are defining our identifier, we did not define hash with it. Another one could be another example could be that when you wanted to state, maybe when you wanted to write, you were writing for for push now, for example. Let's say you wanted to define a variable and you started the variable name with a number. This is not going to be acceptable because when we were defining our number, when we were defining it, when we were defining the identifier, it must start with a letter, it must begin with a letter, not with a digit. So these are examples of lexical errors. So starting with one or starting with a number here is going to invalidate whatever we've written. This will be invalidated because hash pound is not declared in our identifier. Then this will be invalidated because Identifier must start with letters, not digits. So this is um, this is an example of lexical error. Okay. Then the second part, which is syntactic for syntactic error. So for syntactic error is basically syntax error. Like when you write the wrong syntax, when you declare the wrong syntax in your code or in your query or whatever it is. So for this one now, an example could be when, let's say for example, you want to declare a variable, then you are declaring the variable as a keyword. This is a wrong syntax because risk is a keyword. You cannot use a keyword as a name of a variable. You cannot use a keyword as a name of a variable. It's just like when you are writing SQL code now. I cannot use where as a table name. The reason is because where is a reserved name, is a reserved keyword in SQL. I cannot use select because select is a reserved keyword in SQL. I cannot use from because from is a reserved keyword in SQL. In Python, print, for example, print is a reserved keyword. So I cannot say variable print or integer print because print is a keyword. So the same thing for this DSL, because we've already been given what our structure is, what our language is, which is within the confines of what was defined. So for that, we cannot call either risk or model or simulate. We cannot name it a variable name. So that is an example. So another syntactic error could be, let's say I write model um, did now, for example, and then I write 10.5 or whatever. This would give an error because it is expecting an equals to here. So there's a syntax error. I didn't complete the syntax that I'm supposed to use to declare this variable or whatever it is. So that's basically how syntax error. That's basically how it works. So we understand lexical error and then we understand syntactic error. Does anyone have a question? Question, please. Any question? So I'm guessing that we are good on that part. So it means we are done with number one. So for number two, I understand a bit of the logic around number two, but part of the questions, if this question comes out like this, I'm not planning to answer number two and number six. But let me quickly explain the way number two works. So number two works in such a way that, so this is syntax analysis and ambiguity. So in programming, there is something called a conditional statement. So when you want to write a conditional statement, you declare an if statement that is if this person is, let's say for example now, maybe we've particularly reserved, I'm trying to look for an example. Okay, an example, I will teach this class if I am available by this time. Okay, yeah, I think that's a good example. I'll teach this class if I'm available by 5 p.m. Else, I will teach it by 9 p.m. Else 9 p.m. So what it simply means is that I'll teach this class if I'm available by that 5 p.m. So if I'm not available by 5 p.m., it means that the time I'll be teaching the class would now be 9 p.m. But it's going to be ambiguous if I'm saying, so this is an example I put out now. So this is an example. I'm just going to type the example so that we see it very well. So it's going to be ambiguous if I write something like this. I will call I will call you if it rains, if You are home, else I will send an email. This is going to be ambiguous because you really cannot understand the train of thought. This person is saying, I'll call you if it rains. Quite all right. If you are home, else I will send an email. It's ambiguous because you can pick the first meaning that I will only send this email if it doesn't rain, because I will call you if it rains, else I will send an email. That is, if it doesn't rain, I will send an email. It can also mean that I will only send the email. Of course, it means that I will only send the email if it doesn't rain, and if it rains but you are not at home. So if it rains and you are not at home, I will send the email. You can see that it's a bit hard for you to understand what exactly this statement is. So that's basically the understanding behind ambiguity here. So if you check the statement, it is showing that the statement, if expression, then statement. So if expression, then statements, else the statement then assign. So it's saying that you should demonstrate using two discrete phrase trees how this grammar is ambiguous for the statement. So if E1, then if E2, then S1, S else 2. You can see how ambiguous it is. So you can probably just try to figure it out, that explanation. But the problem with compilers and ambiguity is that it will be very, very hard to debug. Imagine you are trying to debug this particular issue now. It will be very, very hard for you to debug. Then also, maybe a developer is working. To one person, it might mean a certain thing. To another person, it might mean the second statement. So there will be a kind of confusion and clash with the actual meaning of that particular ambiguity. Anyways, that's more like the basic explanation I think I can give for that number two. So let's quickly move to number three. So for number three, let me check. So for number three, it states that it's a semantic analysis and type system. So a statically typed programming language supports integer, float, and Boolean types, implicit widen from integer to float, no implicit narrowing conversion. So the following code narration. So there is this following code fragment that is submitted to this the compiler. So what we submitted to the compiler, I think I can delete all of this. Okay, let me just move to another side. So what I can, I'm coming. So we have this statement. So we have this following break. So we have float x. We have the float x. We have integer y. We have boolean. We have boolean z. So these are the declaration, and then we have x y plus z. So now there are two errors, there are two semantic errors that we have here. And the first semantic error is in y plus z. And that is because what we have here, y is an integer. Integers are basically numbers, they are basically whole number. That's what an integer is. They are basically whole numbers. And booleans are true or false, or one or zero, but it's basically true or false, right? So these are booleans. You cannot add, there are different data types. This is an integer and this is a boolean. You cannot add up an integer with a boolean. So that is the first issue that you have here. That is the first semantic error that you have there. You cannot add an integer with a boolean. Trying to see if I explained. Okay, yeah, I don't think so. Okay, you cannot. So the first problem there is incompatible types for the addition. So you can. It's a type mismatch. There's a type mismatch. You cannot add an integer. So this is a type mismatch. You can't. add, you can do an addition of an integer with a boolean, So that is the first semantic error that we have. Now, the second error that we have is that, let's assume that you can even add x and y. You cannot convert, you cannot, after you must have probably added them up. There is also, you want to turn the answer to a float, because x, remember that our definition for x is that it is a float. So there is also a type mismatch in, there's also a type mismatch in the assignment, that is the equals to in the assignment. So there's also a type mismatch in the assignment. You cannot assign a result. You can't assign a result of integer and boolean. You can't assign a result of int plus boolean to a float. They are different data types. So you can assign it to it. So those are the two. So we're told to identify all the semantic errors, and these are the justifications. So the justification for the first one is there's a type mismatch. You can't add an integer with a boolean. Then the second one is there's also a type mismatch because you can assign an integer and a boolean to a float, because x is a float, right? So they now said that we should describe how a symbol table is used in semantic analysis to determine this kind of error. So a symbol table is basically, I wrote here that a symbol table. So a symbol table in actual sense is a data structure that creates and maintains compiler for storing information regarding variable names, function names, and the likes. So basically, what a symbol table does is that it saves up. Now, when you are writing your code, you define x as a float, you define y as an integer, you define z as a boolean. A symbol table already saves up all of these things that you've defined, right? So having saved that up, now they want us to show how um, they want us to show how a symbol table, how is used during semantic analysis to detect the particular errors that we have here. So let me clear this. So the way it's going to get this error now is that, so the first one is that there is a declaration, there's a declaration storage. There's declaration storage. Basically, at the point you are declaring your x or y and z, it is saving up, it is saving up what each one does. That is, it saves up s as a float, saves up y as an integer, then saves up boolean as as a boolean. So at the point you are declaring your storage, it has saves it up. It has saved it up. That's the first process. Then the second process is now type out look. Type lookup rather. Type lookup. So at the point of type lookup, so when we'll do our x equals to y plus z, the next thing is going to check up is going to check the type if there is a mismatch in the type. So that is what type lookup does. So it checks the type of whatever we are adding together and see. So it checks the type. Then after checking the type, it retrieves. There's an attribute retriever. Attribute retriever. So attribute retriever basically it retrieves what it has saved up before, what it has saved up at storage declaration. Okay, we have less than 15 minutes. If this ends, I guess I'm just going to send a new link. I'm going to send a new link to the group if this stops. So attribute retriever, so it retrieves the previous information that it has before. So it retrieves the type that it has before, that it has stored before in the declaration storage. Then the next thing now, it checks for the semantic. It does a semantic check to check if those semantics are right. That is, if there is a match between whatever was retrieved. I mean, it checks, you know what it does here? So it stores, it looks up what we have here, what we are adding, like the type of what we want to add. Then it now does a retrieval to check what we saved up before. Then it now does a semantic check. At the point it does a semantic check, it finds out that whatever we are trying to match together does not work. So it's not going to allow it. So it's at this point that it detects the error that we have. And then the last part is scope declaration. According to what I saw, I really did not. I think what it says here is that it ensures that X, Y, and Z have been declared in current scope before they are used. But I think I really don't understand this. But I think I understand up to the semantic check type. Do we get this? Do we get this, please? Do we get this? Please let's talk. Oh. Okay, I'm guessing that we all got this. So the the next part is advantage and disadvantage of implicit type type conversion. Okay, so let me explain what implicit type conversion what it is. If you are writing a code now, for example, specifically Python, for example, now, if you're writing a code on Python and you did 5 divided by 2, normally these are two integers that are divided together, but you find out that the result you would have would be a float. I don't know what this answer is, but it's going to be a float because of the division. So this is an example of an implicit type conversion. So an implicit type conversion is that it converts one data type into another data type automatically. So this is an integer and this is an integer. We are dividing an integer with an integer. So an implicit type conversion automatically converts this into a float. Explicit would be we declaring that, okay, let's say we've declared int into y as let's say we've declared int y equals to 5 and say, okay, let me say this is going to be a float, not and float float y equals to, I mean float x equals to 2. Here we've explicitly defined the type. We've casted the type that is this particular type for y. We've stated it originally that y is a float. But here it is automatically going to assume this typecast, that is automatically going to convert, it's going to cast these types, this integer type that we have, it's automatically going to cast it as a float. So that's the basic explanation of what an implicit type conversion, what it is in language design. So the advantage is that um, it is simple and convenient. I mean, you don't need to start retyping the ints or floats or the data types. You don't need to start typing it. And then it probably makes your code easily readable. You can easily read this. You don't have to write long text. It is also faster for prototyping. And then it probably creates like a cleaner code. I think the easy readability is the same as cleaner code. So you can read your code. Your codes are much more cleaner. So let me list the advantage again. So it's simpler and convenient as you don't need to type out the type conversion manually. Then it's faster prototyping. It makes you write quicker and flexible code without worrying about strict data mismatch or something. Then you also have a cleaner code read. You can read your code like very easily. But here's the disadvantage. The disadvantage is that it introduces silent bugs. Like before you know it, your data types are automatically converted to what you don't want it to be converted to. So it introduces silent bugs. Another thing is that the loss of precision, there is a loss of precision because the actual precision, let's say for example here now, the actual precision I want, let's say I don't want it converted to a float. By the time I want to multiply this to another words now, it's the precision, the actual precision, the initial precision I want is already lost, which is an integer. So there is a loss of precision or loss of data inherently in it. So I think those are like I think I've mentioned two for the advantage and the disadvantage. Did we get this, please?
Yes, we do.
Okay.
Yes.
Okay, let me check the time. So, okay, let me just enter a new link. I think that would be better. So that let me just create a new Google Meet. Um, I want to create a new one and then send the link here.
All right.
Okay, so we can exit to the new one. I think someone can probably just drop. You can just drop this link on the group because I'm not sure if everybody caught the link before exiting that. So I'm going to continue now. I'm going to share the screen and continue. So the next question is so the next part is okay, we are done with question 3. Now we are moving to question 4. Question 4 is an intermediate code generation. So a compiler uses three address codes as its intermediate representation. So we are given the expression um, a equals to b plus c star d minus e then divided by f. So um, a three address a three address code, what it does is that it helps in code optimization. So they want us to generate a three address code for this particular expression. They want us to generate a three address code for this particular expression. So our expression is a equals to this. So we want to simplify. It's basically just like saying simplification in mathematics. So what we want to do is we want to simplify this to the easiest form. I'm hoping other people have joined. Okay. So we want to simplify this to the easiest form. So the first thing we want to do is T1 should actually be a subscript. There should be option for subscripts. Okay, this should actually be a subscript. So T1, so let's make our T1 B plus C. Now Let's make our T2 equals to D minus E. Now our T3, our T3 would now be equals to T1 star T2. And that's because we've already declared what T1 is, B plus C, and then we've declared what T2 is, which is D minus E. So we've declared both. So it means our T3 now is T times T2. So T4 would be equals to T3 divided by F. So this is our T4. Then it means our A now would be equals to T4. So this is what we want to achieve. This is what we want to do. So this is the three address code generation. Please give me a few minutes. Let me open it up. Come. Few minutes, please. Please close it. Thank you. So I'm sorry. Yeah, so now we now have A equals T4. So we've been able to optimize all of this code into this, assuming that this is written as B plus, assuming that this is written as B plus C now, for example, we will not need to declare this T2 again. What we would now declare as T2 will now be, what we would declare now would just be T1 dot T1 T1 dot T1 divided by F. That is what we would have divided, and then our T3 would have just been T2. But because, so I'm just showing you how this TAC, how it works. So, but this is what we are going to get. So this is our A. So now we are told to, did we understand this? Did we understand this three address code expression now? Did you understand it?
Yes.
Okay, good. So so we are taught to convert this to direct graph or something and explain its importance. So I'm just going to, so to convert this, let me shift this to this side. So we want to convert this now, what we already have here. So we are going to start with A, and I want the words to, okay, let me just duplicate this. So A and B, and then um, arrow here, arrow here. Then we want to have a plus. Yeah, it's a plus, yes, plus. So let me just circle this. Yeah, just take my drawing as it is. No background view. Okay, here. So we want to have this. Then we also want to have this also for D plus C. I mean B minus E. So instead of plus, this would be minus. So this would be T1. This would be T2. Now, constructing this higher. So our T3 is basically these two, multiplication of these two. Okay, better. So instead of this is going to be star. Yeah, so this is our T3. Then the final, then T4. So T4 would be this, and so division. Then we have F here. F. Then so it means our A. Yeah, okay. So this is going to be equals to our A. Then okay. Yeah. So this is what our DAC, this is what it should look like. This is what our DAC should look like. So what this does is that we're told to, let me see, here's that again. We're told to, after converting, we're told to explain its significance. So the significance of this is that it provides more compact representation. This is supposed to be T4. Yeah, it's supposed to be T4 here. Okay. So it provides a much more compact representation, and then it reveals data dependency. Like you can see which part of the data is dependent on which. You can see this T3 is dependent on the information that we have in T1 and T2. T4 is dependent on the preceding information that we have here. So what I wrote here is it provides more compact representation. It eliminates redundant computation. Like I said the other time, assuming we have a B plus C here too, this is actually D, not B. This is D, please. So I think I did not change it at the point where I was here. So it eliminates redundancy in computation, that is repeating the same thing that we already have. If we've already declared T1 as B plus C, we just rewrite as T1. We don't need to keep rewriting again. And it also helps for code optimization. It also helps for code optimization. So then the last one, which is C, states two reasons why intermediate representation is essential in modern complier. I think we can also read that ourselves. I'm going to probably just send the answer on the group to the ones I wrote so that I don't keep typing. So I'm just going to send what I wrote right here in my own notes. Then number 5, which is the final part I will do. I'm not planning to do number 6. So number 5, I hope we don't have any question on this. I hope we don't have any question on this. Okay, good. So another thing is I think I can even write when we are done. I think I'll just write out the answers here. I can share this. I think I can share this particular worksheet with us too. So okay, number five, which is code optimization. So code optimization. So our compiler produces T1 equals to 0, T2 equals to B plus 5, T3 equals to B plus 5, T4 equals to T2 star 1. So we're told to identify all possible optimization that can be applied to this code. We want to optimize this code to the best we can, the best way we can. So the first one is okay, T1 is 8 times. T1 is 8 times 0. Yeah, T1 is 8 times 0. So the first one is we can optimize T1. We can optimize T1 to be equals to A because 8 times 0 is A. I mean 0 rather. I'm saying A. Okay. Okay. Sorry. T1 is 8 times 0. 8 times 0 is 0. So this is called I'm coming. So this is called constant folding. Any number multiplied by 0 is 0. Basically, that's the idea behind T1 equals 0. So that is constant folding. T1 is 0. Then the next one is that T3 is B plus 5. We are basically repeating T2 because we already have B plus 5 as T2. So we can rename our T3 to be equals to T2 since we already have T2 named as B plus 5. And that is common sub-expression elimination. I'm writing this because I don't know if this explanation for it will be needed, if it will be needed for us to write it when we are writing our answer. So this is common sub-expression elimination. Okay. Then the next one is so we've done that. The next one is T4. T4 can be equals to T2, and that is because normal algebraic, here it is stated that it is algebraic simplification because any number multiplied by 1 is that number. So algebraic simplification, T2 times 1 is T2, right? So and then so we basically don't need to mention T4 again. Actually, we can just say T2 anytime, anywhere we need T4 because that would be copy propagation. That's what is written here. But anyways, then our T1 that is equals to 0 can be eliminated because it's a dead code. We don't need this again because it is 0. So we don't need that query. We can totally remove it. So what's our new so after identifying it, we were told to rewrite the optimized version of our code. So this is what the optimized code would look like. So the optimized code now would be because we've eliminated T1 because it's 0. So it's going to be T2, which will be equals to B plus 5. then T3, which will be equals to T2. Probably don't need to write that. Then T4, which is also T2. T4 is T2 because by the time you multiply this, it turns to this. So this is going to be our final code. This is going to be the optimized version of our code. Did we get this, please? So the last one, which is the C, is to explain why excessive optimization may sometimes degrade performance. So excessive optimization may sometimes degrade performance. I'm trying to see. Uh, okay. The first one is that it's it can increase compiler time because of FT optimization, rolling and unrolling. For example, because we've declared, so when it checks for T2, you know, yeah, sorry, we've stated each one. When it's running this code, the first way, it runs this. But because we've optimized the code now, when it runs this, when it comes here, it goes back to run this again because T3 is equals to T2. So the first one is increased compilation time. The second one is obscure debugging. I'll write all these ones that need explanation. I'll write the ones I have here. You can probably just check it out on your own. Then code bloating from inlining. So I'm going to write all of this. So I think that's the end of the questions. Number five. I don't know number six. I did not even bother checking it. But it's a bit understandable if you check the explanation or the definition online. So yeah, so I hope that we are able to like understand this thing from the beginning. I think it's probably much more easier for us this way. I'm hoping. I'm hoping that even without reading excessively, we can answer some of the questions based off just checking what we've done here. So I'm going to share this I'm going to share this section. I'm going to share it as a read only. Then add I'm going to add up the ones that I need to type. I'm just going to add it to it. Then for probably people that might want to watch, that might probably feel like rewatching again, I'll probably upload it on an unlisted YouTube so that we can just watch it if we feel like rewatching it again. Is there anyone with question? Any question, please? No question.
No question.
So I'm thinking that we are all good. So yeah, see you all tomorrow in class. Thank you.
Thank you. Thanks so much.